indicator shows the current position in relation to the measurement range. To ensure that the initial setup position will not cause the extremes of the measured path to exceed the measurement range, move the reflector sled to the last position and check the reading. Check to see that the signal strength has not decreased significantly and that the crosshairs are still within the twin setting lines. If necessary, adjust the position of the optical unit. Return the reflector to the initial measurement position and verify that the alignment there is still within the allowable limits. When the alignment of the optical unit is complete, secure the foot pads with wax or some other temporary adhesive. In the lower right-hand corner of the console, there are 3 switches: the shift switch, the axis switch, and the polarity switch. When these push buttons are pressed in and latched, they become illuminated. Pressing these push buttons again causes them to unlatch. The axis switch setting determines which axis reading will be displayed. When the axis push button is unlatched, the x-axis is displayed. When the axis push button is latched in, the y-axis is displayed. In our experiment, we are interested in the y-axis reading only. The shift switch provides a choice of displaying the absolute axis reading or the relative axis reading. When the shift switch is off, the absolute reading for the selected axis is displayed. This reading is not affected by the zeroing potentiometer. Latching the shift switch on causes the selected relative axis to be displayed. This reading can be zeroed with the appropriate potentiometer. In our experiment, we wish to read the relative angle. The polarity switch allows reversing the sign of the displayed absolute or relative reading. In our experiment, we choose to have the polarity switch set to the normal position. With the reflector at the first measurement position and the display zeroed, the first reading of 0 is recorded. The reflector sled is carefully moved to the second measurement position. The second reading is recorded. This procedure is continued until all the measurement positions have been measured and recorded. Increased accuracy can be obtained by measuring and recording the angles at the measurement positions in reverse order, then averaging the values from the 2 procedures. We now have readings for each of the 5 measurement segments, that is, the transitions between the 6 points along the measurement path. The recorded values are processed as shown. The readings from the 2 measurement procedures are averaged. The average angles are converted to changes in height. The cumulative heights are calculated and entered. Finally, the slope in the data is removed by adjusting each endpoint to 0. The adjusted data points are shown in the rightmost column. The data is now plotted to show the deviation of the surface along the measurement path. This was the procedure for mapping a line along a surface. This procedure is often performed on carriageways to determine the amount of pitch along the axis of the carriage travel. To map an area of a surface, 8 measurement paths are constructed to form the Union Jack pattern. To allow the optical unit to be mounted on the surface which is to be measured, a corner reflector is used. With this setup, the northeast to northwest and northeast to southeast paths can be measured. Other setups will allow measurement along other paths. Values are recorded for all of the measurement intervals along each of the 8 measurement paths. As outlined earlier in the lab, the collected values are processed, then plotted to form a map of the granite surface plate. In this lab, we have discussed the procedure for mapping plane surfaces. We have seen how individual path measurements can be assembled into the Union Jack pattern to allow area mapping. We have described and demonstrated the electronic level and autocollinator, the 2 instruments most often used in these measurements. The homework assignment for this lab is to process the set of Union Jack data shown in Figure A and construct a plan view map of the area's height variations. For each measurement series, convert each of the position readings into a deviation distance, total the deviations, and remove the slope. Organize the data into a table. Plot each adjusted profile. Fit the measurement paths together according to the Union Jack rules. Examine the agreement of the center point values and comment on the validity of the data. List typical sources of measurement error. Map the elevations and state the peak to valley surface deviation. The lab write-up should follow the standard format consisting of the objective, procedure, results, and conclusion. The write-ups must be typewritten or legibly handwritten. These write-ups are due at the beginning of the next lab.